Hello guys, welcome to block 2. In this block, we will do some spatial analysis. In the first block, we learn how to import OpenStreetMap data into PostGIS using OpenMapTiles project. So after block 1, you should have imported database. In this database, you should have edit new layer cycleway. In this block, we will combine already imported OSM data, and we will combine it with our custom data and use it for spatial analysis. Results from the analysis will be also imported to PostGIS, and we will create another layer, which will be called cycleway_POI. This block consists of 7 steps. First, we will add PostGIS connection to QGIS, and we will display our data from previous block. We will also add basemap for the data, just to get the context. For that, we will use MapTiles plugin. And then we will do 2 analyses. One will be in QGIS, one will be in PostGIS. We will analyze GeoJSON in QGIS. The GeoJSON contains bike shops, and then we will import this GeoJSON to PostGIS, and then we will do spatial analyze in PostGIS, and it will be Shapefile containing bike sharing stations. All these data will be added to new layer cycleway POI. So what input data we have? So first we have imported OSM data from previous block. Specifically, we are interested in the table OSM_cycleway_line string with cycleways. These data are already in Mercator projection. And then we have 2 custom datasets. One is GeoJSON with bike shops. This GeoJSON is in WGS 84. This GeoJSON is from the Open Portal of Buenos Aires. And this GeoJSON will be analyzed in QGIS. The second dataset is Shapefile, also in WGS 84. And this Shapefile has bike sharing stations. Both datasets are datasets with points. The shapefile will be analyzed in GIS. Okay, first step, how to add PostGIS to QGIS. If you work with PostGIS and QGIS, this will be pretty easy for you, but for the others, first, we should check that we have PostGIS running. We'll make it bigger. So now we can see that we have a Docker container. It's called OpenMapTiles Postgres_1, and it's running on the port 5432. I noticed in chat there was someone who had a trouble with this. So if you change your Docker compose and use a different port, it should be visible here. So okay, PostGIS is running. Great. It's running on localhost. It's running on the port 5432. The database name is OpenMapTiles. User and password is the same. Small notice: if you are using Cloud Shell, unfortunately this port is not exposed publicly, so you will not be able to connect to PostGIS from QGIS. So if you are using Cloud Shell, you will not be able to do this analyze, but don't worry, we have these. We have prepared the results. So you will just skip this step, and you will do the second analyze in PostGIS. Okay, let's open the QGIS. I will create new profile. So we have an empty project in QGIS, and we want to add the Post GIS connection. Click on the Post GIS, new connection. We can call this some press, running on localhost on the port 5432, and the base name is open. Connection, the name is name, check. That's good. Connection was successful. Good. So let's show our data. In the public schema, now you can see that you are successful in the previous step. You should see all these data in various tables. We use prefix NE for nature Earth data, prefix OSM for data from OpenStreetMap. So what was the table we created? Was cycleway line string here. Good. So we got data from OpenStreetMap into PostGIS, but we got just lines on the white canvas. So let's add some basemap. For that, we will use MapLibre plugin. So go to plugins, manage and install plugins, and search for map. Install plugin, and plugin is installed successfully. You can see it in the browser panel right here. MapLibre plugin brings some predefined maps, but to access them you need API key. The API key is visible in your MapLibre cloud. So you created an account on the MapLibre cloud. Go to account, API keys. There you should see your API key. If you didn't create the account, you can use this key, which is also available in the README. But if you want to fiddle a little more with tiles and maps, it's better to have own account on the cloud. So just copy the API key, go to MapTile plugin, right click. Because if you don't add API key and you want to add map, you will get an error. So that's why we want to right click on the MapTiler account and paste the key. Okay, we get the key and we get the base map. So now we know that we are really Buenos Aires. Okay, back to the slides. So we edit QGIS to QGIS. We edit base map for context. So in your QGIS project, you should see something like this. Base map and lines from PostGIS. Now we want to add the GeoJSON. You can download this GeoJSON from the FTP server and simply drag and drop it to QGIS. The easiest way, you can also go to menu layer, add vector layer, and choose file from your file system, but drag and drop is pretty much the easiest way. We'll download the file. Go in folder. Now I will just drag and drop it. Good. You can see the data here, bicicleterias de la ciudad. And but we can see that there is WGS 84 but our data in PostGIS are in pseudo Mercator. You click on the properties, you can check that source, and you can see that this is not the coordinate reference system we want. So we will reproject. Reprojection, it's bread and butter of every GIS guy or girl. Nothing too difficult. I'll go to processing toolbox, to vector general section, and use the reproject layer tool. Toolbox is this gear image. You can search reproject layer. You want to reproject this layer flat areas, and target CRS is pseudo Mercator. This is the coordinate system that most of the vector tiles use and most of the apps on the web use. We will save the reprojected data in temporary layer. Good, looks good. And we got the reprojected data here in this layer. I will delete the original data so we are not confused with it. And we got our bike shops here. Okay, so the spatial analyze, which we are just about to do, will calculate the distance of the bike shops from the cycleway. But we need to store this information somewhere. That's why we will add a new field to the layer of bike shops. There are several ways how to do it. You can go to right-click on the reprojected layer, go to properties and to the section fields, or you can go via attribute table. I prefer the attribute table, so I will show you this way, and we will add a new attribute or field, which is called distance. The type of this field will be integer. We work in meters. This precision is good enough for us. We will call it distance, but if you want to call it in a different name, I don't recommend it. You have to keep in mind that you call it a different name, but avoid to use underscore in the name in the field, because then it makes some troubles in the analyze. And these distance will be in meters. Okay, so let's add new attribute. As I said, I prefer to do it via attribute table. You can see that the data already contained some attributes. We want to edit this data, that's why I will toggle the editing mode on. And now I will add a new field. It's this icon in the top menu. New field will be called distance. And we can leave this. As I said, integer is fine for us. Length 10 is also fine for us. And now you can see new field distance here. For now, they are just null values, but don't worry, we will calculate the value soon. We'll save the edits and toggle off the editing. Okay, so far so good. Okay, we're all set. It's time to do the analysis. We will use v.distance tool from GRASS toolbox. We will use our reprojected layer of bike shops as an input, as an input parameter from. We will use the data from PostGIS as an input parameter too. We will say that we want to know the distance. We will say that the column for uploading the calculated value is the column called distance, which we created before. Again, go to Toolbox and search for v.distance. So as I said, from parameter is the layer reprojected. To is the layer OSM cycleway line string from Post GIS. Please notice that both input layers are in the same coordinate system. That's important. We want to know the distance, and we want to save it into the column distance. So from reprojected to OSM cycleway line string, here we want distance, and distance is the name of the column. Done. It's enough. The results of this analysis are actually two layers. It's one called nearest, and then line layer with distance. If I zoom in, you can see I will disable the reprojected, and we can see that there is cycleways. We got the point layer. We got layer distance, which show us the shortest line between the point and the cycleway. We are not actually interested in distance. I open the attribute table. I can see that's our GeoJSON, and distance is calculated here. Good. Okay. So the result from the analysis was saved into the temporary file, temporary layer nearest, but we want this layer make permanent. So just right click on the layer and select make permanent. We will save it to the GeoJSON as the input data were in GeoJSON, and we will call it bike shops _w _ distance GeoJSON, and we will save it into the OpenMapTiles /data folder. In case that you weren't able to do the analysis in QGIS, you can download this processed file from the FTP server. This is the file you should get to in this step. So if there was any issue during the spatial analysis, let's download this file and you are good to go. So you want to right click on the nearest, make permanent. We don't want geo package, we want GeoJSON here, and FOSS4G OpenMapTiles data right here. It will be called, I forgot the name, actually. We can keep this. Yes. Okay. I go to my OpenMapTiles folder, and I go to data. You can see the GeoJSON is here. Good. So we have processed GeoJSON on our file system, but we want to have this data from the GeoJSON in the PostGIS. So we want to import this GeoJSON into PostGIS. For that, we will use GDAL program OGR to OGR. And this program is already in one of the Docker images that you pulled. So we will quickly go to the terminal. We are in OpenMapTiles. Copy the command. Good. So this command is saying, hey Docker Compose, run for me this Docker image, which is called import data. After the container is finished, remove it, and also please mount this current working directory to the volume called OMT. And once you are in the container, run shell for me. So we are creating the Docker container, and right now we are inside the container. And check that GDAL is installed there. Okay, good version. We can also go to DDONT. We can see that we got the volume mounted. Now we want to import the data. We'll copy the command again. And we are saying, okay, so we will use the program OGR to OGR. We want to import the data into Postgres. The database name is MapLibre, and we want to import the GeoJSON, which is located on the path omt/data/bikeshops with distance. And because this GeoJSON is already in pseudo-Mercator, we don't have to carry about projection. And these options says, okay, so once you import this GeoJSON into PostGIS, save it into table BA_bikeshops. We will use the prefix BA for Buenos Aires, so we can see that these data are from Buenos Aires Open Data Portal. It was quick. Let's go back to QGIS, and now we should be able to see this table in the PostGIS. So we will go to public, and I got it here. Right click on public and refresh all tables, and I can see that the bike shops are in the database. We imported GeoJSON with bike shops into PostGIS. Now we will import shapefile to PostGIS. This shapefile contains data of bike sharing stations. This shapefile, you can download it from our FTP server here. And I want this folder. Okay. And paste to FOSS4G, OpenMapTiles, data. So now in the data folder of OpenMapTiles, I have a folder with the shapefile. The process of importing the shapefile into PostGIS is pretty much the same as importing GeoJSON. So again, we will use the container, and again we will use OGR to OGR, and there is just small difference. So of course, the path to the shapefile is different. It's in OMT data estaciones de bicicleta zip, and is the name of the shapefile. It's not the correct name, I guess. We will fix it. This option says, okay, save this shapefile into the table BA_bike_sharing_stations. But this shapefile is in WGS84, so we need to reproject the data during the import. That's why there are these two options: source reference system and target reference system. So the data are in the WGS84. This is the source system, and we want to have it in pseudo-Mercator. If you didn't exit the container, you can stay there. You go to data, you should have the Estaciones de Bicicleta zip folder there. You should be able to see the shapefile. This is the real shapefile name. In the slide there is a wrong one, and I will copy the font again, and I will just fix the name. I think that the tab completion should work. So if you write just Estaciones and press tab, you should get name completion. and it's S8. Okay, it was again pretty quick. Let's check QGIS. We can see this data as well, and yes, there are bike sharing stations. We add some data. I will open the we'll use DB Manager from QGIS. You can also use command line if you prefer. We'll show DB Manager. I will connect to the database again, and we'll go to via bike sharing, and I can see which columns it has, and I can see that there is no column distance. We want to once again add this column to the table. We'll do it from this DB Manager. So if you click on this SQL window, console will appear, and here we can write any SQL query. How to add new table column? We will use alter table command, and we will just say, okay, so we want to alter this table with bike sharing stations, and we want to add new column, which is called distance, and it's again integer type. We'll execute it. Now I will check the table again. We might refresh it. Now there is a new column called distance. Once again, if you check the table, there will be only null values, but we will calculate the correct values soon. And for that, we will use Post GIS function st_distance. We will use update query, and we will say, okay, so I want to update the table bike sharing stations, and I want to set the correct value in the distance column, and the correct value is the result from the function st_distance, and we compare the distance between bike sharings. This B is for bike sharing stations, and between C, which is cycleways, to the distance. It will compare the distance between all the lines and all the points. So we want to order it. This is operator for distance, and we want to order it so that order it from the nearest to the longest distance, and we want just take the first one. We just copy the query manager. And check the table again. Okay, we got some distance. Lovely. So now we have in our PostGIS database two tables. One table with bike sharing, one table with bike shops. And now we want to combine these tables into new layer in our vector tile schema. We already created new layer in the block 1. It was the layer cycleway. So now we will add another layer, cycleway poi. I will do it a little bit faster because you already know how to do it. So in layers, we will create another folder, cycleway poi, and there will be just two files, cycleway poi YAML, which keeps the layer definition, and cycleway poi SQL, which keeps the layer function. Tom already described this. We'll go to GitHub. Because also pretty lazy to write it down. Cycleway poi. Oh, first let's first make the YAML. So it's pretty much the same its layer definition. We want to say that the ID of the layer is cycleway POI. We can add some description. Again, this layer does not have any labels, so buffer size 4 is just fine. And now in the fields we will define which fields will be stored in vector tiles. So for sure we want to have the name of the bike shop or the bike sharing stations. There will be also attribute hours, which says what opening hours are available for the bike shop. There will be also attribute class, which will be there to make difference between bike shop and bike sharing. So the class will have two possible values, bike shop or bike sharing, and of course there will be the calculated distance. So we are in OpenMapTiles. Go to layers. We will create a folder. Go underscore POI. Here, create new file. And sample POI. We will the text from GitHub. The file. Like that in the schema there is the other SQL file, cycleway POI, which we will create just in a minute. So what do we have here? First two lines are just comments for the schema for the images Tom showed you before. So if you want to have these pretty images describing the schema, paste these. Don't forget to paste these lines. And again, we want to create a function which is called layer cycleway POI. And the input parameter there will be again bounding box of the tile and zoom level. This function returns table with these fields. These fields are the same fields that we define it in the YAML file. And what is this table consist of? So it's a union of select. First select is from the table bike shops. The other select is from the table bike sharing stations. We want to show these points from the zoom 12 higher. That's why there is this where condition. And if we set any feature from the table VA underscore bike shops, we won't set the class bike shop. And if we take any feature from the table VA underscore bike sharing stations, we want to set the class to the value bike sharing. We also rename the field. So nombre will be name in the table. WKB geometry will be just geometry. Horario de will be hours, and in this table hours are under name horario. So we will just rename it, and of course the distance. I'll save the file. So I already described what's in the SQL function, and we are ready to rebuild our schema. Here we are still in the container. So just exit. Fill up the container and write docker ps a, and you can see that there is just one container running. That's the container with Post GIS. The container with GDAL was removed after we left it, and now we are ready for the recreation of the build folder. Now we are not ready. Oh my god, I forgot. Because I have to use this OpenMapTiles YAML file, and right now there is not added our new layer. There is, if we forget this, there will be no point. Add layers away underscore boy away underscore. So now we told OpenMapTiles a definition file OpenMapTiles.yaml that this layer should be added as well. Okay. We will run clean, which removes the build folder. We will create a folder again. And you can see that here is written created 16 SQL files for parallel execution at build SQL. In the previous block, when you run the command make, there was only 15 SQL files. That's because we added new layer, so there is one SQL file per layer. So now we have 16 SQL files, so that's good. And we are ready to import all these SQL functions. So in the block 1, you imported OSM data, but now we want to import all these SQL functions that we either defined or are defined in the OpenMapTiles project. And this is a step which can take, I would say, a few minutes, hopefully just 1 or 2. And you have to run these steps every time you change anything in your schema. So if you change any SQL layer or any YAML file, you have to always run make clean, make to recreate the build folder, take the changes into account, and run make import SQL. So if you have any error in your SQL, error will be propagated here. Hopefully there is none. And again, it depends on the data that you are importing, because in the other layers there are SQL functions that do some pre-processing. So if you have a lot of data and the pre-processing is very demanding, this can take a while. But we have just Buenos Aires, so hopefully it will be just a few minutes. As you can see, there is a lot of new function created, a lot of new indexes, but no error. That's good. Okay, so after this step, we will have database ready for vector tile generation. We will generate the vector tiles in the next block. Peter will show you how to do it. But make sure that you have these database ready and imported. Okay, so as we can see, everything was fine. This file run_last is always executed on as a last file, and in this file we create function get MVT. So good. After this step, we will generate the vector tiles. We will show you how to host them on cloud, how to style them, but make sure that you have your database ready.